Okay, we're going to begin talking about the conservation of matter and stoichiometry. To begin this, we need to first talk about balancing chemical compounds. So the first idea is we have to be very familiar with the way that compounds are written. Okay, so there's a specific notation. One of the things that we need to be aware of is the number that's written below to the right of the element. This number that is below and to the right, okay, this is called the subscript, okay? A subscript, the number written below and to the right of the element, indicates the number of that atom, how many of that atom you find within the compound. So, for example, if I give you the compound oxygen, O2, this means that there are 2 oxygens in this molecule. If I gave you CuCl2, the Cu with no subscript indicates there's only 1 copper, but because I have a subscript of 2, there are 2 chlorines. Now, related to this, to help us figure out what the appropriate ratio of elements is, we know that ionic compounds will only form in ratios of elements, okay, so comparing the elements that form neutral total charge. So if we look at our example above, ionic compounds, we look at the oxygen, O2, this is a nonmetal and a nonmetal, so this doesn't apply. But copper is a metal, chlorine, nonmetal. This means these are this is a positive and a negative ion, and they have to essentially balance each other out. So when I compare their charges, copper has a 2+ charge. Chlorine has a 1- charge. However, there are 2 chlorines, so we take that 1- charge and you multiply it by 2 to give you a 2-. Since we see here that we have our copper with a 2+ and our chlorine with a 2-, combine those, 2+ and 2- add up to a 0 overall charge. So that tells us this is balanced. Now, we can work the other way, and we can say, let's say we were given the elements sodium and the element sulfur. The first thing to do is determine what is the charge of each of these elements in their ionic form. Sodium, with its being in group 1 valence electron means it gives away the electron to form a 1+ ion. Sulfur, on the other hand, is in group 6A. If it's found in group 6A, it has 6 valence electrons and it needs 2 additional electrons in order to have a full valence shell. So if it gains 2 electrons, sulfur will have a 2- charge. Now when I compare these, I see that I've got 1+ with 2-. If I add the charges up, I'm left with a 1-, which indicates I need more sodium. In fact, if I just add another sodium, that makes it 1+ times 2 and 2-, 2+, 2- adds up to 0. So the way that I would write this, because remember, we want these to be put together in their chemical form, is we would say that we have sodium. Since there are 2 sodiums, this is the number written below and to the right. The subscript would be Na2 and a single sulfur, Na2S. So one thing to also keep in mind is covalent compounds don't have charge, so you don't have to worry about them balancing out like this. All you have to check with covalent compounds is they have to have filled octets with their bonded and unbonded electron pairs. So this, again, think back to our Lewis structures and the way that we figured those out. If I have an element that involves carbon and 4 hydrogens, when these come together, the Lewis structure shows carbon is the central non-hydrogen, the least electronegative. I have 4 valence electrons from carbon, and I have 1 from hydrogen times 4, so I have a total of 8 valence electrons. What I'm going to do with these 8 valence electrons is I'm going to start with my central carbon, surround it with the 4 hydrogens, and show the bonds. 2, 4, 6, and 8 bound electrons, no unbound electrons, leaving me with 0. The Lewis structure is correct, the bonds are all correct, everyone has a full valence shell, and the formula with a carbon and 4 hydrogens would be C with H, and to indicate there are 4 hydrogens, it's CH4. Now I will let you work out these practice problems. Then we're going to go ahead and I will show you how these should be solved. So I'll assume that you've taken the time now, you pause the video. We'll begin just by identifying the bonding type. So here I have sodium and chlorine, so this is a metal and a non, which means this must be ionic bonding. Now I have a metal iron and another metal in silver, which means this must be metallic bonding. Next, hydrogen, a nonmetal, with nitrogen, another nonmetal. This indicates this must be covalent bonding. And then I have oxygen, a nonmetal, and chlorine, another nonmetal, indicating this must be, again, covalent bonding. So our second question, you're going to have to basically understand what does the subscript tell you. So how many hydrogens are found in each of the following compounds? Well, since the number that is below and to the right, the subscript of hydrogen is 2, there are 2 hydrogens in this compound, H2O. Now I have NH3, because the hydrogen subscript is a 3, I have 3 hydrogens in the compound. Next, I have LiH, and because you don't see a subscript, that indicates there's only 1 atom of hydrogen in LiH. Number 3, we're going to identify the name and number of each atom. So we want the name and the number for each atom in these compounds. So looking here, we see Mg, that is magnesium. And I don't have a subscript, so there's only 1. Then O, oxygen, no subscript, so there's 1. Now Ca, that's the symbol for calcium, no subscript, so there's 1. Cl is the element chlorine. Subscript is 2, so there are 2 chlorines. P, phosphorus, no subscript, so that's a 1. Cl again is chlorine. Subscript of 3 gives 3. Now here I have H is hydrogen. The hydrogen, pen decided to stall on me there. The hydrogen has a subscript of 2, so there are 2. My S, sulfur, no subscript, so that means the sulfur is a 1. O, again using oxygen, and that oxygen has a subscript of 4, so there are 4 oxygens. Next we have, in CuNO3, we have Cu is copper, and my copper has no subscript, so it's a 1. Next we have N, nitrogen, and nitrogen has no subscript, so that's a 1. O, we have oxygen, subscript of 3 means there are 3 oxygen atoms. K, potassium, and I have a subscript of 3, so there are 3 atoms of potassium. N is nitrogen, and there is no subscript, so that means there's only 1 nitrogen. It's going to be very important that we understand the subscript. The subscript notation tells you the number of atoms within that compound. Now we want to write balanced ionic compound formulas in the pairings that follow. So we're going to take our barium and our chloride. So this is, again, identify the charge, and then make sure that the charges add up to 0. So barium is in group 2A, which means it must give away 2 electrons to make a 2+ charge. Chlorine is in group 7A. It has to take 1 electron, and that gives it a 1- charge. In order to balance these, then, I must have 2 1-, 2+ and 2- is going to add to my 0. So that means that the barium doesn't have a subscript because I only have the 1, but I multiplied the 1 minus by 2, so I need 2 chlorines, subscript of 2, in the balanced formula. Now we have aluminum. Aluminum is in group 3A, so it has 3 valence electrons, which it gives away to become a 3+ charged ion. Fluorine is also in group 7A like chlorine, so the fluorine needs to take 1 electron to get its full shell, which gives it a 1- charge. In order to set that equal to 0, for these 3 pluses, I'm going to have 3 minuses, so we multiply that by 3. When I put these together now, I see that there will be 1 aluminum with 3 fluorines, so I write that as AlF with a subscript of 3. Next, we have cesium and oxygen. So the cesium is in group 1A, which indicates it must give 1 electron away to become a cation with its positive 1 charge. Oxygen, you see, is in group 6A, indicating it needs 2 more electrons to fill its valence shell. If it gains 2 negative electrons, it gets a 2- charge. So in order to equal a 0 charge, I need to have 2 1+ to balance out the 2 minuses. This indicates that my cesium has to have the subscript of 2, and the oxygen, because we don't multiply it by anything, is left alone with no subscript. Next we have magnesium, found in group 2, which indicates it gives 2 electrons away, which gives it a 2+ charge. And sulfur, which is in group 6A, that must take 2 electrons to fill its valence shell and gives a 2- charge. You notice that we have a 2+ and a 2-, so this already equals 0. We can have a 1-to-1 ratio and no subscripts are needed.